Alright, and again, let's begin here. So polynomial rational functions here, we're going to learn how to really factor down big, humongous polynomials. Sometimes to the 53rd power, sometimes to the 108th power. How do you convert those down finally to their prime factors? Well, we've got to use the division algorithm. And then the faster way is something called synthetic division. Anybody remember synthetic division from algebra? Maybe sometimes. Oh, okay, some people. Okay, it's about 30%. Okay, so we'll do that. And then we're going to learn something called the remainder theorem and the factor theorem. We're going to combine these guys together. Real quick here, show of hands, how many remember something called the remainder theorem from algebra? 1, 2, 3, 4. Okay, how many remember the factor theorem from algebra? Okay, let's go for it then. First things first, what we want to do is we want to be able to factor polynomials. So if you have a polynomial called f of x, I want to factor down so it's really a multiplier of two polynomials. D of x times another something called q of x. So really we're just splitting it off. If you can split it off and keep on splitting it off and keep on splitting it off, that's perfect. That's exactly what you want to be doing. Okay, sometimes we'll have something called a remainder. Now, when you have a remainder, you understand that there are no factors anymore. Those guys are not factors of each other. So we're going to try not to get remainders here. That's the whole purpose here. Okay, so with that, debating whether I should show you. Let's just jump into an example here, because I think that'll probably be the best. So, just the whole concept of the division algorithm. What is the division algorithm? We're going to divide one into the other. We're going to see what's left over. Eventually, what we want left over is a 0. Because you know for the remainder of a 0, that means you got two factors on your hands. Okay, so division algorithm. Sometimes we'll try to use the synthetic division. But division algorithm, if we forgot, it kind of looks like this here. What we want to do, and your book does it, it puts down your divisor, which is x squared plus 1. But what it is, it writes all the terms of that divisor. And then you put into this long divide symbol. And then what we want to do is we want to write down every single term over here in order. So we got 3x to the cubed plus 4x squared plus x plus 7. And once we got that in place, now we're ready to divide. Alright, and just to remind you guys, remember what we do is we just take the leading terms. We don't care about anything else. We take the x squared and we look at 3x cubed. The question is, what do you multiply x squared to give you a 3x cubed?
3x.
Yeah, you need a 3, and then you also need an x to give you to the cubed portion. So what we do, we write the 3x, and I like to do it this way. The book does it as well. This is neat. You write underneath each column. So this is the x column. Let's write the 3x here. So 3x times x squared gives you 3x cubed. 3x times 0x, well, that's just going to be plus 0x squared. 3x times 1 gives you a 3x. Let you guys catch up. Then again, hopefully you have at least skimmed 3.3, maybe. All right, remember long division from a long time ago? What do we do next? Subtract. We got to subtract this whole thing. If you can do subtraction in your head, awesome. Go for it. If you're kind of not sure, remember what you could always do is you can add the opposite. So all you do is you just change all the signs inside here. Sometimes easier, sometimes more difficult, whatever, depending on what you want to do. But the first term better cancel off because you did something wrong, because that's the whole point of canceling this term off. 4x squared plus a negative 0x squared gives you a 4x squared. Let's see, a positive 1 plus a negative 3 makes a minus 2x plus 7. All right, and then the whole process begins again. X squared times what gives you 4x squared? A positive 4, huh? Also, it is a constant term, so it goes right above the 7, because that's really we're at the end of the number here. So 4 times x squared is 4x squared. 4 times 0 is 0x, and 4 times 1 is 4, and then we subtract. All right, and again, you can subtract or you can add the opposite if you like. The 4x squareds better go away. Negative 2x plus a negative 0x, still negative 2x. 7 and a negative 4 make a plus 3. Okay, you know you're done two different ways. You either reach the end of the number here, or when you go to multiply this, x squared times what would gives you a negative 2x. Hey, can't do that anymore, huh? Because your degree or multiplier here is actually a higher degree than here. So that means you know you're done. So the quotient is 3x plus 4, and your remainder is the negative 2x plus 3. Good, good? Hopefully you guys got that before me. Okay, I want you guys to try yourself here. This was going to be a little tiny bit more complicated. I'm going to go here. Gave you a little clue here. So let's find the quotient and remainder when 2x squared plus 5x, x to the 5th plus 7 plus 4x cubed is divided by x squared plus 1 minus 2. All right, and I gave you the clue here. The first step is to make sure your terms are written in decreasing powers of x. So you want to go from highest to lowest. The other thing is then you want to insert all your zero coefficients. So there's step 2. And besides that, I'm going to just let you try here. Look at your neighbor's paper if you need to. All right, and 3.3 really is a setup for 3.4. We're going to actually, these are sort of the fundamentals, and then we're going to actually use them in 3.4 to find zeros. All right, I'm going to give you at least another clue here. So your divisor is x squared minus x plus 1. And your dividend, which is the stuff underneath the divide bar, All right, give you guys the answer here. Kind of look up when you're done, or look up if you're stuck. Again, ask me the questions if you need to here, but I got a quotient of x cubed plus x squared plus 4x plus 5. Remainder is x plus 2. All right, everybody good there? Any questions on that one? Anybody not done yet? Cool, okay. Let's do one more just to try, just to make sure we got it here. And then we'll do one little extra thing at the end here. So let's divide that by the trinomial of x squared minus x plus 3. Should be right here. I'll give you a little bit of pieces here. Hopefully you did not forget you need a 0x cubed in there somewhere. Let me give you at least a little more of the answer here. Look up just to make sure you're on the right track. All right, and then again, x squared times 3 gives you 3x squared, so plus 3 at the end there as you multiply everything through by 3, and then subtract or add the opposites. You eventually wind up with that as the remainder. Alright, so instead of putting Q being something and R being something, what we want to do is we want to write it as still a polynomial. So the way we do this is we write the quotient, and just like, if I can take you all the way back to 4th grade. I remember 4th grade. Remember that? Remember 3rd grade we used to write like 23R6. Remember that? And then we got sophisticated in 4th grade. We used to write 23 and let's say 6 over 31, right? We wrote that as the divisor. So we're going to do the same thing here. We're going to write the quotient, which is x squared plus x plus 3 plus, because it's a polynomial, it's saying this right here, plus your remainder divided by your divisor. Okay, we good there? Does that make sense there? Same thing as 23R2 now being 23 and 2/31. Okay. Alright, this is called long division. First of all, because it's a long time to do it. Alright, there is a shortcut. That is called synthetic division. But it only works at certain times, not always. So what times does it work? It only works right here. Divide a polynomial, fx, only if you're dividing by x minus a. Or you could say x plus a, but it has to be a linear function. So if there's an x squared in here somewhere, synthetic division does not work. Cool. And notice it's given as x minus a. So really, when we're going to look at their divisor, we're going to take the opposite of whatever's here. So if this is x plus 3, technically negative 3 is the number we want. If this is x minus 4, positive 4 is the number we want. It's always the opposite. Alright, again, only works in this case if you're dividing it by a linear function only. And so let me give you, because about 30% of you guys raised your hand when I said you guys remember synthetic division here. Let me give you an example first, and then we'll try it ourselves here. So example, here we go. We're going to divide 2x to the 4th minus 3x squared plus 5x minus 63. Again, don't need to write it down unless you really need to. We're going to take this x plus 3. Ooh, that's right, it's x plus 3, huh? So the a value here is actually a negative 3. We good? It's always the opposite. We're going to take this negative 3, put in a little corner right here. Then what we do is we bring down the coefficients. Because technically, whenever you did the division, the long division, weren't we actually just dealing with coefficients only? The x cubed and the x squared and the x gave us which columns they were in, right? But really we added and subtracted coefficients. So let's go. X to the 4th has a coefficient of 2. Hey, x cubed is missing. So we're going to write a little 0 in for that one. X squared has a coefficient of negative 3. X to the 1 power has a coefficient of 5. And the constant term all the way at the end here, negative 63. So here's what we do. We bring down this 2. We add down. So 2 plus nothing technically. 2 plus nothing is still a 2. We take this negative 3 and we multiply up. So negative 3 times 2 is a negative 6. 0 plus negative 6, what's going to happen here? Negative 6. And then negative 3 times negative 6, what's going to happen here? 18. And negative 3 plus 18. Ooh. 15, right? He just wanted somebody else to get a chance. I understand. 18, negative 3, and at positive 18 gives you a 15. 15 times negative 3, what's going to happen up here?
Negative 45.
Negative 45. Negative 45 and a 5 make negative 40, right? And then again, multiplying negative 3 times negative 40 gives you 120. Negative 63 plus 120 gets you 57. What in the world are these bottom numbers? We just divided out an x plus 3. So this guy here, this is your new remainder now. 57 becomes the new remainder. Negative 40 becomes the new constant term. And then I like to write it like this. I sort of write it backwards here. So negative 40 is a constant term. 15 is now the coefficient of x. Negative 6 coefficient of x squared. 2 is now the coefficient of x cubed. We good? So notice also what we did. We started with x to the fourth, and we moved really one down. We moved it down to x to the third. So if you want to write it this way, that's fine too. You started off with x to the fourth. That means this is 2x cubed minus 6x squared plus 15x minus 40, remainder is 57. You can write it a forward way as well. Okay, let you guys try it yourself here. All right, another question here. How many saw synthetic division? Now it became familiar to you. Like, oh, now I remember synthetic division. Okay, that's what I thought. Good, good. All right, people in the back in Kalinga figured it out. Light bulb went on. This is good. All right, let me put it down. Let's see. So x minus a is what we want to look for. So it's of x minus 3. The a value is really 3. Or another way to sort of look at it is what we do is we just set this guy equal to 0. X minus 3 set equal to 0. And what's the x have to be? X equals 3. So we use that a value. So it's not just because it's subtraction, it's because when you solve it for 0, that's your a value. So 3 on the outside, inside a little corner. See if I did this correctly here. I got a 2 for my coefficient of x cubed. Negative 7. Don't forget your 0 because there's no x to the 1 power. There has to be a 0 in there somewhere, and then you get 5 at the end. Good there. All right, I have 3 erasers going. That's okay. That's over here. All right, and then all we do is we start adding down. So 2 plus nothing is still a 2. 2 times 3 is 6. Multiply back up here. Negative 7 plus 6 is negative 1. Multiply back up. Negative 1 times 3 is negative 3. Add straight down. 0 plus negative 3 is negative 3. And then 3 times negative 3 is a negative 9. Adding down gives you a negative 4. All right, can you write that polynomial with the remainder? We start off as being x to the 3rd power. Now we know it's x to the 2nd power, right? Because we went down by 1, right? It was x cubed. Now we're down to x squared. So I can write as 2x squared. There's my coefficient of x squared. Here's the coefficient of x, so it'd be negative x. I don't want to put the 1 down. My constant term is minus 3, plus my remainder, which is negative 4 over x minus 3. Are we good there? And again, 3.3 is really a setup for 3.4 because we should be able to factor down any polynomial if it will be factored down. That's what we're sort of dealing with. We're getting skills to do that with. Okay, just for you guys to try it again. From beginning to end, no help whatsoever. All yours. give the answer here, see if you guys agree, or if you want to ask me about it here. Eventually, I get a 2x cubed minus 3x squared minus 10x plus 20 minus 22 over x plus 2. All right, and again, your book uses a little bar line right here to distinguish it from these numbers here. Sometimes other books put a little box right here. They put a big box saying that whatever's in the box is the remainder. And some textbooks don't even have this bar at all. It's just a straight bar line across, and then you're good to go. So just depending, but in a sense, you are still doing synthetic division either way. Okay, any questions on this one? Anybody did not get the right answer and want to know why? And raise your hand if you're not done yet. Okay, go for it. Finish it off. Got 3 people raising their hands. Go for it. Cool. All right, let me jump to something called the remainder theorem. And whoa, let me go to here. There's the remainder theorem. Let me see where it's found in the textbook here, so you can look at it if you need to. There. It's on page 328. 328. And here's what it says. If I'm dividing a polynomial called f of x, and I'm dividing it by x minus a. Hey, that's kind of synthetic division, isn't it? If I'm only interested in the remainder, I don't really care what the numbers are going to be. I'm only interested in the remainder. I don't have to do synthetic division. I don't have to do long division. What I can do, I can just plug in the a value into the function itself, and when that's done, it's going to give me my remainder. So I don't have to do long division. I don't have to do synthetic division. I just plug in the value. Only if I'm interested in just the remainder only. And we'll see why that is in 3.4. All right, I'm going to show you those here. Let's get going here with, let me jump to, don't write this down, kind of think with me here, and then we'll do the next one as practice here. So find the remainder when this polynomial, blah, 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 is divided by x minus 1. So again, can I use synthetic division on this? Absolutely. Can I use long division? Yes, I can always use long division. Synthetic division I can use sometimes. But if I'm only interested in the remainder, that's all I care about. What I can do is I can plug in that 1 value. Notice it's x minus 1. It's the same value that we use for synthetic division. We're going to plug in the 1 into the function itself. When I plug in the 1, 1 to the 5th times 2, subtract 4 times 1 cubed plus 5 times 1 squared minus 7 times 1 plus 2. After all that work, I get a remainder of negative 2. In 3.4, as we start doing these here, we're going to use the remainder theorem. But what we want to do is we want to figure out which one's going to give you a remainder of 0. That's going to be the important part there. Which one gives you a remainder of 0? Okay, practice one for you guys, all yours. Tell me. Whoa, this is x to the 110th power. That's cool. Anybody want to do that by synthetic division? Nah, got some smiles looking at me. Mr. H, you are crazy. Anybody want to do that by long division? Yes. Okay, you do it by long division, Jose. The rest of us will use the remainder theorem. Okay, so no. In fact, we're not interested in what the division is going to give us. We're only interested in the remainder. So if we're only interested in the remainder, what should I plug in for x? Yeah, I got to plug in a positive 1, right? Even though it says x minus 1. Again, you look at that divisor and say, okay, what's going to give me a 0 here? What gives me a 0 is a positive 1. Let's plug that in. And you guys tell me, when you guys get it, tell me what you got. Unless I made a mistake, that's not what I got. I got 4 as well. 4? Okay. Sorry, Jose, that's 3 against 1. So plug in the 1 into here. Gets me a 1 minus 2 plus 5. In this case, a negative 1 plus 5 is a 4. That's kind of cool. Again, we could have divided this all, but eventually at the end, after 3 hours of labor probably, we would have found ourselves staring at a 4. Okay. It also works the other way, if you think about it. And this is the other way it works. Let's go the other way now. Let f of x be this monster right here. And what we want to do is we want to figure out what f of negative 3 would be. Well, hold on. The remainder theorem says if I want to figure out the remainder, all I got to do is plug in that value. Is that right? Let's go backwards then. I could figure out the remainder, and I will know the value then. We're good? So that negative 3 becomes the term that I use for the synthetic division, and I bring down synthetic division. So that's going to be 1, 3, negative 5, 8, 75. And again, bring down the 1, multiply by 3, add down, multiply by negative 3, add down, multiply by negative 3, add down, multiply by negative 3, add down eventually. There it is. So f of negative 3 is equal to 6. Everybody agreed? Again, it showed you both ways here. One way is to evaluate. They plugged it in. And this one they did it by synthetic division. Each case they give you the same thing. Okay, so our problem here. Can you use synthetic division to find for me f of negative 2? I'll give you a hint. I guess I should give you a hint. X to the 3rd power, or x cubed, is missing. Just to throw it out there, just so you don't have to work a whole bunch in order to get the wrong answer. I'm going to start it here. Let's see. So instead of plugging in a negative 2 to my function, I could just do this. So bringing down the 1, multiply negative 2, bring down the negative 2, multiply negative 2 gives you a 4, then a 14, negative 28, eventually a negative 26, multiply by negative 2. How about a 52? When you add down, gives you a 32. Everybody good there? So okay. That's synthetic division, but what I know now is f of negative 2 is All right, one more concept to deal with here. We'll be done. Next one is something called the factor theorem. So what's so special if you get a remainder of 0? If you get a remainder of 0, that means those two things multiply each other without any remainder whatsoever. Hey, it doesn't mean that those are factors of each other. Again, how we see it in just a second here. Let's do an example from the book, just sort of looking at it, and then we'll do one for practice here. So let's see. Given that 2 is a 0 of the function of this guy here, 3x squared plus 2x squared. Sorry, a little mess up here. I think this should be a cube here. Change that over here. That should be a cube. So 3x cubed plus 2x squared minus 19x plus 6. I want to be able to solve this for this equation right here. I want to be able to finally factor everything down. Let's see what we're going to do. Again, just in your mind, don't need to write it down, just kind of think with me. We're going to take this 2 here. Since we know it's a 0, we're going to plug it into the synthetic division. Bring down the 3, multiply by 2 gives you 6, add 2 makes you 8, multiply by 2 gives you 16, add a negative 19 gives you negative 3, and voila, look at that. 2 times negative 3 is a negative 6, and remainder is 0. Can you write for me the polynomial that remains? Let's see. We went from x cubed, right? So this has to be 3x squared. This has to be 3x, and this has to be the constant term. But what we just figured out, this right here. See if you guys agree with this. Right there is right. This polynomial with 4 terms now has a factor of x minus 2, and the remaining polynomial is right here. Hey, you know what? Can I take this guy? Isn't this a quadratic now? I have a whole bunch of stuff for quadratics. I can factor them down. I can take the quadratic formula. Is that right? At this point, there's going to be 2 on the homework where you're going to eventually get down to here. But here you're going to have to use a quadratic formula to finally finish it off. Okay? So kind of be careful there. Factor, quadratic formula, or something called the square root method for solving an equation, right? You might have to do that one. Anyways, factor this down some more, and eventually factor down, and there it is. My 2 other zeros, if I know 2 is a 0 out of this, my 2 other zeros will be 1/3 and negative 3. Okay, let you guys try it here. Can you solve this one? Solve for me 3x cubed minus 2x squared minus 20x plus 12, minus 12 equals 0. If you know for sure that negative 2 is one of the solutions.